Hello guys, this video is about an LG 39-inch LG TV which doesn't have backlight. It turns on and we have sound, but there's no picture. Or actually there is a picture, but there's no backlight. We can easily see this by pointing a flashlight towards the screen, and we will see the picture in the background, which means there's only the backlight which doesn't work, which may either be a problem with the LED backlight or with the power supply. The voltage for the backlight comes from this board here, which is the power supply board. The current is supplied through these two wires. As you can see here, for a 39-inch TV, the nominal voltage is 135 volts and 370 milliamps. First of all, we're gonna check if the power supply is working and if it tries to provide current to the LEDs. And there we have it. It's it's 200 and something volts, and it tries to restart several times, which means we probably have a problem with our LEDs. So now we have to take apart the whole screen assembly. We remove first the front bezel. Then we have to remove the metal frame, which means we have to remove all the screws around it. Then we have to remove the PCBs, the T-con here. Remove the two flat cables. Careful not to break anything. Now the metal frame was unscrewed and we remove it carefully. Now we have the front glass exposed. These little boards are attached via these flat cables to the LCD glass. We will have to carefully loosen them. They might have some conductive tape underneath. So now that they are loose, we can remove the glass. Ideally we could use some suction caps or a second person. Using gloves is always a good idea too. The best would really be to work with two persons. So very carefully we lift the glass and put it aside. Then we remove the plastic frame that holds all these white sheets underneath, diffuser sheets. And as we can see here, there's 1, 2, 3, four sheets in all, and the reflector sheet underneath, the white one, which also has to be removed. In all we have 4 by 9 LEDs, so that makes 36. So we remove the little standoffs, and then we are able to remove the white reflector sheet in the back. And we unplug the little connectors to the LED strips. There are 4 in all. Usually these LEDs can be tested with a voltage from about 2.6 volts upwards. We just multiply this value by the number of LEDs we have in one strip. So here we found one that's defective. It doesn't turn on, so it's shorted. And here we might have some open LEDs, maybe. Yeah, I have to test them individually with about 2.6, 2.7 volts. You can use a power supply with current limit, or just a power supply with a resistor in series. So here we seem to have another one. No, that one is okay. And that one is defective too. Okay, in all we have just 2 LEDs to replace. Now the LED strips, unfortunately, they are glued to the, apparently with some double-sided tape. When we lift the PCB up, we should be careful not to bend it too much, or we might damage other LEDs. So this is the PCB. We could try to remove it with a gas station, but that's not my preferred method. So it's way easier with a hot plate. Then afterwards we clean the contacts. This is the original LED strip. We could try to buy this too, but that's actually not worth it. Just replace 2 LEDs. And I have an old LED strip here where I am gonna take the LED from. Just putting it on a hot plate, heated to about 280, 290 degrees, and it becomes very easy to remove two LEDs. Now this LED doesn't have, it has the larger pad on the plus side, and the LEDs I have as replacement LEDs, they have the anode on the smaller side. So this is something we have to pay attention to. Now we just put some solder paste on it, on the PCB contacts, on the PCB pads. Put the LED on the PCB and pass it on the hot plate, and once the solder paste is melted, remove the PCB. Now testing them individually. And then testing the whole strip. The one with the 5 LEDs we tested at about 14.5 volt, and the other one at 12 volt, which has only 4 LEDs in series. Now that's it. Glue the lenses back on. Usually I use this kind of glue, and then test the whole strip. Before reassembling the screen, don't forget to plug in the little connectors. The reflector sheet, the little standoffs. And then we just assemble everything the same way we disassembled it. Or when placing the LCD glass back on the frame, we have to pay attention to the exact position. It has to be in the exact position where it was before. And we can usually see it in the corners. Now place the PCB back into position, then the metal frame, and the front bezel. We turn the whole thing around and place the loudspeakers, T-con board and the other PCBs again. Make sure these two flat cables are inserted correctly. Now 370 milliamps, I think it's maybe too much, even if it's PWM controlled. The peak current is pretty high, I think. Where the controller chip is the MAP3202. The resistors in the red circle, these are the resistors that determine the LED peak current. If we increase the value of these resistors, the peak current will be lower. So here I removed all of them and I put another resistor. And the maximum current, as we can see here, is 50, 100, 150, about 160 milliamps. That would be the maximum we could drive through the LEDs continuously if duty cycle is at maximum. Here we see the voltage on the LEDs, and it's about 120, 40, 60, 80, 100, 120 volts, the maximum voltage, and it works. Thanks for watching, guys, and subscribe and click the like button. Thank you.